Earthquakes. That is what happens to people who live in California or in foreign countries like Japan or Indonesia. It doesn't happen to us, right? Wrong. Fracking, the conversion of natural gas and oil from shale rock, has made the shaking of the earth an issue throughout most of the United States. Earthquakes are the concern of engineers, lawyers, business people, city planners, architects, and countless of other professionals in areas where we live. The best way to learn about these destructive convulsions of the earth is to use the engineering design process. An engineer first has to identify and define earthquakes with guiding questions. What are they? Why do they occur? And mold them into the big idea. How do we measure the earthquake? The challenge for a class of future engineers is to build an apparatus that can accurately measure the shaking of the Earth's foundations. That machine is called the seismograph, a machine that is based on scientific principles and higher mathematics. After defining the problem, it is vital to gather information, data, and research that has already been discovered. This also includes lessons on logarithms, inverse functions, and other mathematical scientific concepts. Then one must select the best solution, communicate it to others who are working on the same problem, and then implement it. Of course, all good engineers need to refine their solutions and redo the process again and sometimes again. Surprises can occur. In this case, an internet web page did not make sense. The math just didn't work. More research was done and it was determined that the original internet research was flawed. It was corrected. We cannot control the Earth's crust and prevent earthquakes, but we can strive to use mathematics to measure them with higher precision, to engineer safer structures, and to minimize the loss of life. So how did you think about the seismograph unit?
I thought it was really cool because it was different from anything that we've done previously, because most of the time we just worked out of the book.
Well, the logarithms, it was kind of hard to understand at first, but I pretty much fully understood it by the time it was time to take a test on it.
Sense, and then we figured out that earthquakes aren't measured in millimeters, so that's why it wasn't working, and we had to measure it in microns, which are half